Today I would like to talk to you about ChemCurator and a little bit about the Markush technology behind that. First of all, ChemCurator. Compared to the previously mentioned two text mining solutions, the SharePoint technology and the Plexus mining, instead of indexing millions of documents for searching purpose, ChemCurator designed for processing smaller set of documents and give a high quality representation of the chemistry covered by this kind of documents. This is a computer-aided manual extraction tool, and it's based on previously existing ChemAxon technologies, including your English, Japanese, and Chinese naming technology, developed Markush editor, structure checker, and or search and representation technology. How it works. Here you can see one of the extraction views of ChemCurator. In the middle of the screen, you can see the annotated document. This is a Google patent currently. Under that, you can see a selected structure view, and in the right-hand side, you can see a compound list extracted from the document. If you select any of the highlighted structures inside the document, it's under the document in the extraction view and selected structure view, and you are able to simply drag and drop these structures to the extracted structure view. The big benefit of this tool is maintaining a two-way linking between the extracted structures and the original content. That means if you select any of these extracted structures, the tool automatically scrolling to the relevant part of the document and highlights you. You're able not only to extract the chemical structures, but you are also able to add custom columns and adding assay data or any additional information or comment depending on your needs. Many users want to extract not only specific compounds, but also Markush structures, mainly from patent documents. We have a specific extraction view for this kind of workflows, called it Markush extraction view. This side, you can see a Markush editor view. The same way, you are able to drag and drop selected fragment definitions from the document to the hierarchic representation of Markush fragments in the editor, and you are also able to add exemplified structures to this view. The tool is continuously validating your exemplified structures against the Markush structures. Matching ones are highlighted by green, and non-matching ones are highlighted by red. If you select any of these particular structures, we can display you how it's matching or how it's not matching to the Markush structure. ChemCurator primarily designed for extracting chemical information from patent documents, but you can use it not only for patents, but also for journal articles or company reports, depending on your needs. Because it's based on the naming technology, it's able to handle a wide range of different kind of input formats, including XML, PDF, or HTML documents, and we also have some import wizards. You can import structures, not structures, documents directly from Google Patents, or if you have access, you can import from the IFI claims. Based on the third-party OSR tools, you are able to recognize and annotate not only the text-based information, but also the images inside the documents. That was the ChemCurator. If you find it interesting, please try outside the demo station. I will be happy to show you more details. Daniel presented the naming technology behind this tool. I want to tell some word about the Markush technology behind it. I'm quite sure we have the best Markush technology currently on the market. Here is our brief overview of our Markush representation. We support R groups, atom list, bond list, position variations, link nodes, repeating unit, homology groups, everything what is necessary for you if you want to represent a patent Markush or a combinatorial Markush structure. we are not only able to representing the Markush structures, but we also able to search them without enumeration. But if you want, we are able to enumerate these Markush structures. We can visualize the hits related to your search results, and based on thanks for the last recent developments, we are able to visualizing why not matching your structure to a Markush. We can visualize the overlap or calculate the overlap between Markush structures, and we are able to automatically generate Markush structures based on the list of compounds. The technology what is capable to visualize the differentiating structural parts, this is the non-hit visualization. It's currently available in ChemCurator because it's really useful if you want to find inconsistency inside your extracted data or you want to analyze the extracted data. Here you can see a non-matching exemplified structure, and as you can see, some of the structure, the part of the matching part of the structure is highlighted by green, but here is a black hydroxyl group, because this hydroxyl group is not represented in the Markush structure. But inside the Markush structure, you can see the matching parts are also highlighted by green, and the non-matching fragment definition is highlighted by red. This way, really easy to find why this structure is not matching to the exemplify. The benefits of this technology, there is no enumeration behind it, and that's why there is no size limitation. You can get a really quick result based on your selection. This technology partially based on the newly developed Markush Overlap. Markush Overlap is capable to calculating the overlapping chemical space between two or more Markush structures. We are able to give back the percentage of overlap, and we are able to Markush structure representing the overlapping chemical space. This is no enumeration and no size limitation. Here you can see how efficient this technology. With a small Markush structure, our comparison is not too good. It's 0.2 seconds. But with a really big Markush structure, with not really big, but quite big, with 1 million enumerates, it takes only half a second. And as you can see, the scaling of this chart is logarithmical. It means you can compare very complex pattern Markush structures, what was not available with any tools before that. The last thing what I want to introduce you, the newly developed Markush Composer. It's available in Markush Editor. You can try it in the demo station too. It's capable to generate a Markush structure based on the list of structures. Here is a trivial example, but you can do the same with hundreds or thousands of structures. It's capable to automatically find the optimal scaffold, the common part of the input structures, and capable to automatically add the R group definitions. The big benefit of this technology, the generated Markush structure, not only cover the original set of structures, but cover all possible combination. This way, you can build up combinatorial libraries really quickly. That was I want to show you today, and if you have questions, I will be happy to answer you later, or next to the demo station. Thank you for your attention.